I want to present to you today the Aibotix V2, our common use product for mobile mapping applications and a worldwide new HP GNSS module, which you can see on the top of the copter. The HP GNSS module is used for high precision mapping applications, and it's possible to save up to 40% of mission time with this new module. It's a plug and play solution, so you just have to plug it into your common drone, and you have the possibility to use it in RTK, real-time kinematic models, and also as a post-processing solution. So what we have here is the antenna of the module, and it's completely included high standard, Leica standard GNSS receiver with the capability of use GPS and clonal simultaneously in dual frequency mode, and also with the capability to have up to 50 Hertz of update rate to get the highest accuracy of up to 1 centimeter in position and altitude. Prior we had a common use GNSS module which used GPS and a single frequency, as it is commonly used on most of the drones, with an accuracy of about 2 to 5 meters. And if you want to use the normal module, if you use it with such an accuracy and use it for direct georeferencing, so you have your images direct reference, you also need ground reference points on the ground. And this takes time to measure these points, and you can avoid them with the new HP GNSS module. The ground control points are avoided due to the high accuracy you reach in real time on the drone itself. So with a common GPS you have 2 to 5 meter, and with the HP GNSS you have a centimeter accuracy in real time when you are flying, and you can reference really accurate the coordinate where the image is taken. And the Rtk capability, we have the Rtk capability via our ground reference station. So you have your ground station, a common laptop can be used, and you have a direct link to the copter. And when you use our software iProFlight, you can reach the centimeter accuracy in real time via an N-trip service, or alternatively you can also use a GNSS base station via radio modem or direct link. You can integrate any base station you want. The only thing you need is RTCM 3.0 or 3.1 protocol, and you can use with this protocol any N-trip service or base station, so also the base station you already have. We have an existing radio link to our ground station via 800 megahertz radio link, and you can use your ground station as a transmitter for this data, and use your ground station one option via internet N-trip services, and on the second option with the base station, GNSS base station. So the module itself is plug and play compatible with all Aibotix 6 and can be used from now on. Especially if you have vast environments and you have to save as much time on site as possible. You have to use such a module, because the most time consuming steps you have to do on ground on the site is to lay the ground reference targets. So for example, if you spend 1 day on the site, mostly half of the day or more is used for ground reference targets, and the mission execution is just minutes. Here's the module, how you will receive it. You can order it with a new copter, or you can also update it on your existing Aibotix V2, and it's as simple and light as possible, because you have to mention that every weight we have on the copter itself will give you less flight time, and this module only weighs 180 grams. and you can have the same flight time with this module or not. So here you see the antenna, dual band antenna, and it's as simple as possible. On the bottom side you just have the plug here and the possibility to store your GNSS raw data on an SD card. And if you mount it, just put it on the roof and click on, and it's ready to be used. You can also buy the, if you have an existing Aibotix 6, you can also buy the module itself and use it as a plug-and-play compatibility. So what you see here in the air is our brand new and the worldwide first fully solution working hyperspectral camera on an copter. In collaboration with Headwall Photonics from USA, we use the Headwall Nano sensor. It's a hyperspectral line sensor with up to 460 single line bands to integrate it completely on our copter and fully integrated in our solution, so you can use it with the copter itself. Hyperspectral imaging gives you the advantage to get hypercubes, and with such hypercubes you get so much data that you don't need to know prior to when you're flying a mission what you want to search for, because you get so much data you can look for anything you want. The hyperspectral imaging works in 400 to 1000 nanometer band range, and this is the near infrared band range, and captures up to 460 bands simultaneously. So it is a complete integrated solution. You have data storage on the sensor itself. You have a separately Imu Sensor, high-class Imu Sensor, and also GNSS receiver to geo-reference your data and to store it on the sensor itself. And you have then the possibility to download the data up to 500 gigabytes and process the data with the existing solutions from Headwall Photonics. If you use a normal multispectral camera, example with 4 or 6 bands simultaneously, you have to know what you are looking for on the ground, because you change and decide what bands you want to capture with the camera. With such a camera you can capture many bands simultaneously, and you don't need to know what to capture, so you just fly your mission and decide afterwards what you want to look for. The complete workflow is included in existing software solutions from Aibotix and Headwall Photonics. So the mission planning and flight execution is completely included in the iProFlight software from Aibotix. And afterwards, when you made the mission, you can use existing software solutions from Headwall Photonics for analyzing and georeferencing the data. So we are using a high-class line sensor, and with such a line sensor you have the challenge of the stability of the system itself. So we made a complete new gimbal and use the gimbal for stabilizing the sensor itself. And the existing sensors and multispectral sensors on the market have the challenge with a limited bandwidth. And the new hyperspectral sensors, and especially the Headwall sensor, has the capability of capturing many bandwidths at once, and also the weight of the sensor itself is really light. So the sensor itself only weighs about 600 grams, completely included, and you reach a really high flight time with such a sensor. And it is completely integrated on the multicopter, and this is the worldwide first solution.